Um, it is, although at some point they said, okay, no more, you can't go to virtual anymore. And I don't know when that window opens back up, if it does.
Okay,
or when it does. So if you're interested, talk to your counselor, because I don't know when it is. Oops, I hit pause.
I'm not worried about it. I was just curious.
Yeah. So let's look at the syllabus here. First test is not until, I guess, 2 weeks from today. It's a little bit tricky. You look at the syllabus because it has Wednesday and Thursday, and some days are block day / late arrival, and some days aren't. And so I've tried to label that and keep that clear. We don't have a block day this week, so we'll have separate stuff going on Wednesday, Thursday. Next week we do have block day Wednesday, Thursday, and that's why it's labeled block day and then late arrival. And for Thursday's day, it just says see Wednesday because there's nothing new going on that day. And then the next block day, we'll have a test on Wednesday for us, since it's first period. We won't have anything on Thursday. There is a potential 2-day test coming up. Probably test 3 is a 2-day test. Test 2 is probably not a 2-day test, but Mr. Conley and I need to figure out exactly what's going to go on that day, but that's a long way away. So for now, the next test is August 25th for us. That's kind of the only thing we need to worry about. Again, today and Thursday go together really well, and so I'm kind of just going to see if I can get through all of it today. If we can, great. If not, we got a whole another day to figure it out. If we do get through all of it, then this homework, you might just push off and do it in class tomorrow, and we can work on it together, that page 55. So I kind of just listed everything on Wednesday, and whatever we don't hit today, we'll just let it bleed over into tomorrow. A lab on limits. So you can work together with somebody, an elbow partner. Most of you have somebody close to you. Let me show you what I mean. Or maybe we'll get the first one together. Use the table on your graphing calculator to fill in the table below. So I'm going to go to y equals, parentheses or fraction bar, however you want to do that. It's been a while, I think. There it is. Alpha F1 gets me the fraction bar. If you want to avoid the parentheses dangers, and type it in. It says use the table. I guess that would be the easiest way to go. Let's see. Use the table to fill in the box below. So the table doesn't have what I want it to have right now. Like I want 1.9 and 1.99, and that's not in there. I guess 2's in there, so I could put that one down. That's 15. But I need to go to table set. So alpha F2. Whoops. Table set. No, that would be second F2. Table set. And my independent variable, using those words we don't use often, that's the x variable, the one that's independent. Let's pick ask for that one. That way you can plug in whatever you want for the x value. And then you go back to the table, and it's blank, but now you can type in 1.9, 1.99, and so on. All right, so and when you get through number 1, let's pause there, go over it, and then I'll let you go the rest of the way. So how did I do what? Get the table where I could put things in?
I put it on ask, and then it just brought up the table.
So second table set, and then put independent on ask. That way it's like asking you for the x's. You can type them in. And then you go back to table, and then you can type in whatever you want for your x values.
She did it, but it's like still going back to the normal table.
So when you finish number 1, press pause.
Oh wait, never mind. Okay, so the table is still there. But
This question, part B, is probably new notation for you. Have you seen that before? Limit. Because that's the thing for today, is like, what does this mean? Limit as x approaches 2. So this just means, I mean, once you get the hang of it, it's not hard. It means as x gets closer to 2, okay, you don't actually have to get there. That's the biggest deal with limits, is you don't actually have to equal 2. Sometimes you do, but you don't have to. It just means as x gets closer to 2, like really, really close to 2, like 1.999 closer to 2, or 2.001 closer to 2, what does this thing get closer to? That's what it's asking. As x gets closer to 2, this gets closer to, and then that's what goes in our blank. 15. So that's not really a hard one. That's more of like, let's learn what the symbols mean. Because x gets closer to 2, the graph gets closer to 15. Pretty straightforward. Part C, what is f of 2? Do you remember what that means? If I take the function, I plug in 2, what do I get? 15. Now, be careful. B and C are not always equal to each other. Not always the same. B and C. The limit and the function, a lot of the times they are, but not always. And we'll look at some examples where something kind of goofy happens, where they're not the same. Part D, graph f of x on your graphing calculator using a friendly window for x and negative 20 to 20 for y. What happens at x equals 2? Okay, I don't know what a friendly window is, so window, it tells me what to use for y. For x, and I'll start with negative 5 to 5. That's not bad. So I went negative 5 to 5 for x. Friendly, that wasn't very helpful. And then negative 20 to 20. And this doesn't have to be perfect. I'm just going to kind of sketch what the picture shows. It looks like it does not cross through the origin. It crosses up above a little bit. Something like that. Again, pretty rough, and that's fine. It doesn't have to be perfect. In fact, that's not going to be real good if I locate at x equals 2. It should be up at 13. Or, no, it should be at 15. So my scale's a little off because my graph was a little off. So I sort of worked that backwards and made my scale fit my graph so that 215 is on the graph. What happens at x equals 2? Well, f equals 15. We kind of answered that question a couple of times already. Sketch the graph. Okay, I did that already. Questions on that one? All right, try number 2. It's the same function, but there's different things to plug in, and it's the same set of questions, but since you're dealing with different numbers, it's going to look a little different. So fill out the table in number 2, see if you can answer the limit question, the function question, and then do the graph and see if you can figure out what is going on with number 2. So we got the table filled in. So at 1 there's an error. I guess let's pause for a second. Why is there an error at x equals 1? Why doesn't exist? What's that, Connor?
0 would be the denominator.
Yeah, it puts 0 as the denominator, and you can't divide by 0, so something strange is going on at x equals 1. Like, we can't have the function there. All right. What about question B, though? So ignore that what's going on at 1, because we don't really care what's going on at 1 with limits. We mean we want to know what's happening when we get closer to 1. So as we get closer and closer and closer to 1, what do we think the limit is? 4. And we have to be careful how we say that. We don't want to say the limit gets closer to 4. The limit is 4. It doesn't get there, but it gets closer and closer and closer to there. In fact, if you wanted to, you could, you can, and this is what some people do on the test and even on the AP test. If you get one that you're not sure about and you can't figure it out algebraically, you can do the table thing, and you can even do, throw in some extra zeros and see, wow, that does get really close to 1. That is very misleading what I just did right there, because at x equals 1, there is no y value. And you see what the problem with my calculator is? I mean, the calculator's not wrong, it just can't display that much accuracy, so it rounds it to 1, even though that's not exactly 1. So that's kind of tricky. But it does show that we're getting closer and closer to 4. So the function's getting closer to 4, that means the limit is equal to 4. But what is f of 1? It's not 0. If we plug in 1, we get 0 in the bottom. We get 0 in the top as well, but it's undefined because there's a 0 in the bottom. Can't divide by 0. So this would be a case where B and C aren't equal to each other. The limit's 4, but there's not really a graph there. Graph it on the graphing calculator, but you're not going to, and what happens at x equals 1? You're not going to be able to tell from the graphing calculator what's happening at x equals 1. Does anybody know what's happening at x equals 1? Well, okay, so there's a gap. That's not a bad way to say it, because you're right, there's nothing at x equals 1. How wide is the gap, I guess? Very small, because it is okay at 0.99, and when we typed in 1.00001, it was good. So you're right, there's a missing piece there, but how wide is that missing piece? So gap's a great way to say it as long as we continue that thought. How wide is the gap? The smallest it could be is like a point gap. We have a mathy name for a point gap. It's not called a point gap. It's a name you've heard before. So you're going along on the graph. You have to leave I don't want to say it because I want you to say it. You have to leave a gap, but it's only just a little bitty gap, and then you pick up on the other side. Let's see if we can draw it. So at 1, we know we're at 4, although we have to leave a gap there. At 2, we're up at 15. So I have to leave a little bitty gap. Smaller than that, though. But even smaller than that. So like, what could I draw on my paper that would be sort of signify that there's a gap there, but it's really small? It's like an open circle, which is called pre-cal.
It's when it's like
So you want to draw it like that? Yeah? What's that called? You forget? It's not a complicated word. You've just forgotten what it's called. Let's back up over here and do some algebra on that thing. That thing will factor. X squared minus 1, x squared plus 1. And then x squared minus 1 will factor. X plus 1, x minus 1. then do you remember what happens if a factor cancels top and bottom? There's a word for that. It's the same word that what it makes right here. There's a hole there. What's that? You knew that? Is in there somewhere? But Andrew, I like your first description of there's a gap. You're absolutely right. There's a gap, except the gap is as small as it could possibly be. It's a point gap, which makes it a hole because we were dividing by 0. So this is a great example of at a hole, like we've learned holes different ways, but here's another way to describe a hole. The limit exists, but the function doesn't. Exist. As we get closer and closer, we're getting closer and closer to 4, and we can get like infinitely close. As x gets infinitely close to 1, the graph gets infinitely close to 4. Now, if we reach 1, it blows up, but we don't care about reaching 1. Limits aren't as x equals 1, it's as x approaches 1. So that's kind of the main point of today is you don't have to actually get there, you just get really, really close there. So what happens at x equals 1? Well, we just answered that. There's a hole there. Sketch the graph. Well, we did already. It also means our first graph wasn't quite right because we didn't know that there was a hole there.
Wait, so is there like the first one was like a limit?
The first one up here?
Yeah.
So there is a limit. As x approaches 2, as we get closer and closer to 2, the graph gets closer and closer to 15.
Alright. I wasn't sure what specifically which one there's a hole.
So there might be a hole, there might not be a hole. Whether there's a hole there or not doesn't affect the limit. All right, try number 3. Or actually, we could maybe start it together. Make a table to help you find the limit as x approaches 0 of this thing. Well, I can tell already if I plug in 0, it's not going to work because there's 0 in the bottom, so I can't do that. But we could get closer and closer to 0. And probably from either side. I know 0 is not going to work, but I'll put it on there anyway. So make that table and see if you can figure out what the limit is. Yeah, as x gets closer and closer to 0, the graph gets closer and closer to 100. And again, if you feel like 99.833 is maybe not close enough for you, then you go to your table and you pick a different value and you get 99.998. Like, okay, I'm definitely getting closer to 100.
I don't know why my numbers are so off. Like when I was entering in all my x values, they're all different than that.
Are you in radians? That could be the mode.
Yeah.
Was that it? Okay, that was an easy fix.
Yeah.
So the limit is 100. It gets closer and closer to 100. But let's back up and answer question B. What is happening at x equals 0? There's a hole there. So the graph isn't there, but the function still has a limit there. Because as I get closer and closer, it looks like we're going to land at 100. The fact that we don't actually get there, that doesn't matter for limits. It's just a matter of getting closer and closer there. All right, why don't you try number 4, start to finish. Very similar to number 3. As you're going to 0, you got a kind of a weird function. There's going to be a place where it doesn't work, but see if you can figure out what it approaches. So you get closer and closer to something, but it's not a something that's easy like 3 or 100 or 2 or 15. We get closer and closer to E. E pops up a lot in calculus. That's why they put that example on here for number 4. Morgan.
How do we know it's E?
How do you know it's E? That's a great question. You wouldn't know it's E unless you knew the value of E. Come in, you're good.
I'm probably not going to be in Book B today. What are we doing? Is it just on Schoology?
It will to that question of how do I know it's E? In the same way that you've worked with pi enough, where if 3.14 showed up, you'd be like, oh, it's pi.
Oh, so 2.71 equals E.
Right.
Okay.
Yeah, you don't. Most of y'all are not familiar enough with E to recognize it yet, like you recognize pi. But hopefully, eventually, when you see that number, when you see 2.718, whatever it is, if you saw that as an answer, you get to the point where you're like, oh, that's E. Just like if you were working a problem and 3.14 showed up, especially if it was a circle type problem, hopefully your brain would register, wait a minute, that's pi. So how do you know it's E? Because you've seen E before, you've seen it enough times to recognize it, which isn't yet. So that's okay. All right, I think the best way to divide this up is to make the assignment today, page 55 on the syllabus or the calendar, 1 through 25 odd. Now, a word about books. There's a way to get the book online, but it's kind of complicated. So there's two other ways that are a lot easier. One way is I'll have books in here that are on the back shelf. So if we have extra time, I don't really know that today qualifies with 8 minutes left, then you're welcome to grab one and work on it or take a picture of it for use at home. Or the other way, I guess I can say this on video, I don't know that anyone's going to throw me in jail for it. I take a picture of it and post it in Schoology. That way you don't have to have a book at home. If you look at Schoology, there's a PDF, or maybe it's a JPEG, whatever. There's a picture of the assignment posted there. So you don't need a book. If you want one, you're welcome to one, but you shouldn't need one. So have a look at those. They're very similar to what we just did. Make a table, plug in some values. Basically plug in enough values until you figure out what's going on. That's how you do limits numerically. So today was limits numerically. Let me adjust the syllabus so we a little more clearly. Today was limits numerically. Tomorrow will be limits graphically. Friday will be limits algebraically. And then Monday will be limits with trig. So limits for the next few days. So try 1 through 25, or at least take a look at them and try some of them. Tomorrow's worksheet is pretty simple. We'll do most of it together. It's this beautiful function worksheet. It's really only beautiful to a calculus teacher. But we'll do half of it together, and the other half will be your assignment. So today's book work, not really that hard. Tomorrow is a worksheet that's even easier.
And it'll just be on Schoology?
Yes.
Awesome.
That work should already be posted in Schoology. In fact, just for the benefit of the person working at home, let's go find it and see if it's there. Let's see, Schoology, courses, pre-cal. Nope, this is calculus. Yes, the workbook pages. You mean the book pages? Yeah, that's what I'm making sure. I think I already did. So we're in current unit. It shouldn't say function, it say limits, but all right, I had the two grouped together, but you can figure that out. Today's August 11th. There it is, worksheet 1.2, page 55. So it's called a worksheet, but it's from the book. Uh-oh, maybe. Page 55, 1 through 25 odd. Taking its time, but there it is. So it's tables. It's laid out a little differently. Make a table. And then this one doesn't say make a table, but I don't know how else you would do it other than using a table. So give those a go. And tomorrow we'll go over those and then look at limits graphically.